Hi, this is Dr. Mantesh. Let's continue with the next experiment, that is 5B. This one, draw layout of inverter with Wn equals to Wp 20 times by 40 times by 20 times. Use optimum layout methods. Verify DRC, LVS. So we do not have any whatever software for verifying LVS at this point because we are using microwave. And let's at least do the layout and verify whether it's working or not. So we'll go to microwave, just close the previous one, file, new. So what they're asking is 40 times by 20 times the minimum. Already I told that minimum would be 0.6 micron in 120 nanometer technology. Suppose if I take PMOS 40 times the minimum, it would be somewhere around 24 micron. Minimum is 0.6 micron, or even we can consider 0.3 if it is minimum. Okay. Okay, now error. 0.3 is minimum. In that case, we'll take 0.3 into 40 times. So it is going to be 12 micrometer. So hope you understood the calculation. What I am trying to do is minimum, which is 0.3. Let me take typewriter. Minimum is 0.3 micron into 40 times. So would be somewhere around 12 micron. So we'll try to take that 12 micron. If I generate with the number of fingers 1, it is going to be a long device. Okay, you can see that it's too lengthy. So that is why they mentioned optimum layout method. So we should go for fingering. So let's go and do it. We'll delete this. So what is the design? Says okay, this also we don't want. Micron. For example, we are going for say 10 fingers. In this case, just check. Okay, looks good. We can still call it as fine, or we can make it 20. Nothing wrong in it. Make sure that it is going to fit in a given area. Let's go ahead and do NMOS. Now 20 times that of minimum. It is going to be around 6 micron. Okay. Then generate device. All. So now I am trying to say. So somewhere here I'll try to keep. Now I have to move and make it very close to this. I want it to be a layout should be easily connectable, or else it is difficult for us to. Okay, let's just check whether it is connecting or not. I am not worried about the area. Okay, it's coming perfectly. I just stretch and connect everything. So theory part behind this is there in your theory. Please go through. I'm stretching, but it's not taking. Okay, let's stretch again. Only one gate is there. Why it is not stretching? Okay, it's coming. So it's like instead of having one big transistor, we can have small 10-20 transistors to get the same effect. Okay. So what is important is placing of this in initial stages. It's feel like okay, it's too tough, but it's okay. We can able to do it easily. If it is not stretchable, you take polysilicon, bit zoom, connect it. Yes. And check for any DRC errors if there are any DRC, no DRC errors. So the connection between input and output drain is over. Now we are supposed to do ground connection and VDD connection. Okay. So we have to take a metal and somewhere you put it here. Go on connecting or stretching these things. So I am trying to do it as simple as possible. Now give VDD and ground connection. This is VDD. VDD for N mil. Same thing holds good. I am coming down or simply say view all. Input I have to give. Zoom it. Give input. Square wave. Okay, inputs are not shorted. So I have to short input. So I don't want to change it. In the part B they did not mention anything about any input specifications. Okay, let's assign as it is, and the same input must be connected everywhere. So I am trying to connect a poly. Just check if there are any DRC error or not. No DRC error. Similar to that you can connect metal one. So please understand that these things are in different layers, not in the same plane or say in the same floor. So you will not get any connection directly. Also I have to apply ground. stretch the things. Okay, I am trying to connect grounds. If it is not coming, just take. Okay, done with connection. Now I have to give ground. Fine. So I think I had completed the layout and given input, but I have to give output point where it must be observed. So I'll give a visible node, connect here as out. I'm trying to change this input as in. Save, just run. Okay, make it 1 pico. So now you could able to see that it is, since 20 by 40, that is 2 times, it falls under the second case what we did in the previous third case. Okay, Wn equals to Wp by 2 or Wp equals to 2 times Wn. So here it is Wp equals to 2 times Wn. So this is required because the P transistor must be twice as that of the NMOS transistor, because holes are sluggish, at least theoretically 2.3 times lower than the electrons. So to produce the same current in PMOS transistor, we need to have more channel area, so more W, and to produce the same current, to get a equal rise and fall delay, TPLH and TPHL, so I should have PMOS as twice the size of NMOS. So now we are getting nearly same, both are nearly same, equal rise and fall delay. So this is all about part B of first experiment. Later on I can share with you. Still you can make it optimal by making 12 fingers or 13 fingers. Don't go beyond that, or else the layout becomes, it will take more area. So that's it. This is all about 1B. So this is what we can do. We do not have any other options like parasitic extraction or post-route simulation. See you in the next video.